All right. Good afternoon, everyone. It is morning here on the west coast of the United States, and welcome to the last talk of JSConf Belgium 2020. My name is Tim Doherty, and I am going to be talking to you about JavaScript exploits and how to prevent them. First, a little bit about me. I work as a software architect at PROCORE Technologies in Carpinteria, California, just south of Santa Barbara. Here's our beautiful headquarters overlooking the Pacific Ocean. I normally work in this building right here with a view of the Pacific. Right now I'm working out of my home office. I'm a father, stepfather, and husband. This is me with my clan at PROCORE's London office on vacation last summer. I live in Santa Barbara, California. It's a fantastic place, absolutely beautiful. Highly recommend visiting if you ever get the chance. In my spare time, I run the JavaScript meetup here in town. I am an avid scuba diver and also an underwater photographer. I've had a few photos published. I keep trying to get more. And I have been, as of July, in the software industry for 25 years. I've had quite a few twists and turns in my career, more than a few missteps, but I can say with all honesty that I have learned just as much, if not more, from my missteps as I have from the successes of my career. So a quick outline. I'm going to talk to you very briefly about application security in general, about JavaScript security specifically, and then we're going to dig right into the top JavaScript exploits and how to prevent them. So application security. Disclaimer, I am not a security expert. It is not my field of specialty. Every time I look at cryptographic hashes and authentication protocols, it does make my head spin a little bit. However, since I've been around the industry for some time, like many of us that have a fair bit of experience, anecdotally and experientially, I know it to be true that it is a lot less expensive and a lot less risky to build in security from the beginning rather than trying to tack it on at the end. So I want to call out this incredible book, Accelerate. It is not a security book, but it does call out the capabilities of high-performing tech organizations, and it does so with statistical analysis, showing both correlation and causation. And one of the key capabilities they call out of high-performing teams is a shift left on security. The idea that building in security from the beginning is one of these capabilities. And they found that, indeed, high performers spent 50% less time responding to incidents. A few key quotes from that section of the book, and this is something I've also found to be true. A lot of developers don't do this out of spite or maliciousness. They're simply ignorant of common risks. There's a project called the Open Web Application Security Project. They publish every few years a top 10, and this lists the top 10 vulnerabilities or security risks in open source applications. And a lot of people just are not aware that this even exists. And then this great quote, again, sort of summing it up, that this should be built in, should be integrated from the beginning to the end. So what about JavaScript security? How bad can it be, right? I mean, we are talking about JavaScript, which is arguably the most misunderstood programming language on the planet. And it's normally running in a lowly browser, sandboxed, so it has limited access to do damage. Except it's not just in browsers anymore. You know, for the last 10 years at least, we've had it running thanks to the massive popularity of Node as a viable server-side language. It's also a first-class citizen in many databases and even operating systems at this point. It is so broad in its deployment that the surface area continues to expand, which means that attack vectors continue to expand. And it turns out that even with lowly JavaScript, using techniques like injection and forgery, malicious people can perpetrate all sorts of crimes, including defamation of character, defacing websites, financial crimes, identity fraud, and even the zombie apocalypse. All right, well, maybe not that last one. But the point being is that even with lowly JavaScript, exploits can be very serious. All right, so let's dig into these exploits one by one and do a little profiling. So our first exploit is cross-site scripting. So cross-site scripting is when an otherwise benign or trusted website has malicious script injected into it, and it results from rendering untrusted user input. This exploit regularly appears on the OWASP top 10, and while the most recent, published as of 2017, drops cross-site scripting from 3 to 7, it is nonetheless in the top 10, meaning it is a widespread application security risk. There are 3 types of cross-site scripting. The first is reflected or non-persistent, where user input reaches the server but is not stored. It's just reflected back into a web page at the user. The second type is stored or persistent, where the user input actually makes its way all the way to a persistence layer, a database or a file system or an in-memory cache. And the last is DOM-based. It's similar to reflected, except it never reaches the server. It's simply reflected right back through some sort of a DOM manipulation operation. And I'm going to dig in now to some demonstrations here and some specific mitigations, but the key mantra for cross-site scripting is never trust your users. Just like you would never trust the raw input of a form to go into your database without validating it, it is really important to treat with care any input that comes to your user, and certainly any input that you render back out to the screen. Okay, so for the purposes of demonstration, we are going to log into our favorite social media app. And we are on this way more than we probably should be. We're going to go to twitface.com. And twitface.com is written on the client side in vanilla JavaScript. You can see here on the left-hand side, we've got just a bunch of template literals that are being stitched together and then inserted into the DOM using an inner HTML operation. So let's go ahead and log in and just see what our site looks like. I'm going to log in as me, and I've got my latest post here waiting for some comments. So the first attack we're going to try and perpetrate is reflected or non-persistent XSS. So we are going to, since most of this client side, most of this cross-site scripting is going to occur client side, this is all built in vanilla JavaScript. I'm sort of cheating on the server. I'm using an Express server, but we're also going to circumvent that a little bit. And rather than using the built-in Jade templating language, which by default protects against these sort of things, we are going to use just a plain template literal here. And you can see that when we log in, we are using the query string parameter user to put a nice welcome message, welcome back to it. So in this case, with our template literal, we're reading that query param, and then here on line 24, we're just spitting it right back out at the user without cleaning it, without sanitizing it, without doing anything. And what that means is that we can do some pretty nasty things. Let's go ahead and swap out the username with, for example, a script tag. And the script tag is going to hit evilserver.com and attempt to run this bad JS file. And when we do that, we get hacked. So clearly, being able to run a script tag gives you all the capabilities that you could do with client-side JavaScript, including reading cookies and all sorts of maliciousness. So how would we protect against this specifically? Well, the common mantra, the basic mantra is never trust your users. You need to clean that, escape it, or otherwise encode it. In this case, what we're going to do is we're going to encode it. So we're going to write a little function to encode it. It should be pretty simple. We'll call it HTML encode. It's going to take in the string as argument. And then basically we're just going to map over that string. We'll split it into an array first on an empty character. Then we're going to map over it. And then each character we are going to turn into a character code representation. And we can do that as follows. The syntax looks like this. It's an ampersand, hash, and then we're going to use a fairly new method from ES 2015 called character code at. So we'll do char.charCodeAt, and since these are a single character, the index is always going to be 0. And then at the end, we'll put a little semicolon to escape it, and then let's use this down on line 23 down here, sorry, 24. And just wrap that in a call to HTML encode. Okay, I've got NodeMon running, which is going to restart our server for us automatically. So let's log back in and try and perpetrate that again. I've got a, oh, that should be split. Sorry about that. Let's restart it. We'll log back in, and we'll try and perpetrate that same attack. So if we try and put that script back in now, what we should see is just a string representation. We've got it still split here. I forgot to join it back again. Let's join it back with an empty character. And now we should get the actual template literal, string literal of that script. Let's log back in. And let's try and perpetrate that attack one more time. And now we just get the script. So this is by far the safest way to do it. Always prevent actual raw HTML from being spit out into the document. There's an additional layer of prevention that you can do here. And that is, since we are trying to load a script from another domain, we can use an HTTP mechanism called content security policy to prevent scripts from being loaded from any other domain. So what that looks like is it's an HTTP header called content security policy, and it has a number of directives you can use to restrict what content can be rendered in a page. So I've written a simple middleware for Express, and all it is basically doing is every response that goes out from the server, and we could target this just to the index page, but every response that goes out is going to include this header, content security policy, and then we're going to use a specific directive called script source. Script source does what you think it does. It prevents or limits the sources from which scripts can be loaded. It is a space-delimited list of hosts or domains or URLs, including this reserved word self, which means just what you think it does. Only load scripts from self. So let's go ahead and turn that on. In our Express file, we're going to turn that on as middleware here. That node.mom will restart for us. And let's put we've got our network tab on. Let's go ahead and try and perpetrate that same attack. We'll try and load that script tag. Now what we should see is that script tag should fail. If we go down here and look at our JavaScripts that loaded, let's go ahead, we missed that, capturing that. And what we can see here is that it refused to load the script, just as we expected it should, because it violated the content security policy, saying that we could not load scripts from any source other than ourselves. So let's turn that back off. All right, so that is reflected or non-persistent cross-site scripting. So let's move on to the second type. Second type is going to be stored or persisted cross-site scripting. This is where untrusted user input makes its way all the way to the server and into storage. So we're here in McTwitbase. Actually, let's log in as one of Twitty's friends. Twitty, of course, is me. And let's just see if we can just do a standard post on here. We're logged in as NOUS, and NOUS really likes Twitty's new post, and all is well. But what if we have some suspicious actors out there? Let's log in as one of these suspicious actors, Mr. Evil Weevil. And Evil Weevil is up to no good. Evil Weevil is going to go and now try and perpetrate some attacks on TwitBase. So as I said, we are building this application in client-side JavaScript with no frameworks or libraries, just vanilla JS. And we're doing it by concatenating a bunch of template literals and using inner HTML to insert them into the DOM. So this by itself presents some measure of protection against cross-site scripting. So for example, if you try to insert a script tag using inner HTML, the script tag will be rendered, but since the DOM has already been parsed and rendered, it will actually not evaluate the script tag. You used to be able to use a deferred attribute on a script tag to perpetrate attacks, but browsers have gotten more sophisticated in the cross-site scripting protection, and that no longer works. But we still have attack vectors available to us. We can use subsequent events, things that happen after the DOM has been rendered, like event handlers. And in particular, we can use the onload and on-error event handlers of images. And that's exactly what Evil Weevil is going to do in this case. So let's go ahead and try to perpetrate an attack like that. We're going to add a comment here. Let's make sure that we're logged in. We're going to add a comment. And what we're going to do in this comment is we're going to insert an image tag. with a broken URL that won't resolve. And we're going to take advantage of the subsequent event handler, the on-error event handler, to run some JavaScript. We're going to do a crude check to make sure we don't run this attack on ourselves as evil. And then we're going to attempt to do something to this page. So we're going to log, you can see evil weevil just gets a broken image, but otherwise nothing else that's obvious. So we're going to log back out. Now we're going to log in back as me again, as Twitty. Now, my company's pretty cool. They are fine with us, surfing TwitFace on our lunch breaks and coffee breaks. As long as it doesn't interfere with our work, it's totally fine to use, company computers to surf social media. But we do have an open office space. And, my monitors are open to anyone, including my boss. And so I'm, careful what I show on the screen. Imagine my surprise if I log into TwitFace and all of a sudden something really offensive appears on my screen. And our attack did not work. Uh-oh. What did we break? The perils of live demos. Content security policy looks like it is still on. So let me make sure to turn that off. Thought I had. Let's just go ahead and make sure to restart the server to make sure it picks that up. And let's see if we can get it now to perpetrate this attack. So imagine I log back in and something really offensive appears on my screen. And if it doesn't, just use your imagination. There it is, Nickelback. Nickelback just pops up on my screen. And I think to myself, oh my gosh, I can't have people thinking I like Nickelback. Let me refresh, maybe it'll go away. But no matter how many times I do it, I can't stop this attack from happening. So this is a simple defacement. Meanwhile, my boss is looking from her office over in the corner and going, ooh, geez, I didn't think Tim was a Nickelback fan. Maybe she's questioning whether or not she should keep me on. All right, so let's go ahead and clean out that attack so that we can start fresh on a new one. Okay, and that should restart our server. All right, so let's log back in and make sure everything's clean. All right, so that one's fairly innocuous. A little bit of defacement, but it really didn't do anything nasty on my behalf. But you'll notice that each time here, we are actually logging in. And that means we've got an authentication mechanism happening. And in this case, we've got crude basic authentication using the passport library. And we are authenticating using sessions. And the way that mechanism works is that every response on a successful session includes a cookie, a key value pair, header that includes the session ID. And when that session ID is implicitly passed back to TwitFace with every request, there's middleware that reads it, makes sure that it's a valid session, and if so, it allows the request to proceed on that user's behalf. And that means that using cross-site scripting, we can do things on a user's behalf that may or may not be savory. So let's see what that looks like. Let's go ahead and log back in as Evil Weevil. And we're going to perpetrate a similar attack. We're going to use an image tag, only this time, instead of the on error, we're going to try not to raise any suspicion at all. We're going to load a successful image, and we're going to use the onload event. So in this case, we're just going to load a smiley face, and then we're going to do a similar check to make sure we don't perpetrate this on ourselves, and then we're going to actually post back to TwitFace something and see what happens. So we post this smiley face. Everything looks great. Looks like Evil Weevil really likes our post, but otherwise nothing else happens here. And let's keep an eye on our requests and see what's happening. Let's log back out, and let's log back in as me and see what happens. So we'll log back in as me, and if we watch the network panel, we should, I've got a filter on here. We see the normal stuff happening. We go and get our posts, our comments, and our users, but then we have a fourth request here, which is a post back to post on our behalf with something possibly not so innocuous in it. Nothing shows up right now, but as soon as we go back and refresh our feed, oh boy. So now my boss is thinking to herself, we're friends on TwitFace. She's logged into her feed. She's already seen Nickelback on my screen and is a little bit dubious about me already. But now she's seeing me on a public forum admitting that I run with scissors. This is a possible intervention happening here. She's thinking about whether or not she needs to put me on a personal improvement program, because certainly this could mean I'm a danger to my colleagues. All right, so that is persistent or stored XSS. Now let's go ahead and clean up again and start for another attack. Let's restart our server. Okay, so the last type of client-side XSS is DOM-based. This is very similar, as I said, to reflected, only it never makes it to the server. So if we look at our index route here, we're going to now turn off the Jade templating engine, and instead, we're just going to send the file out. So this is analogous to a static website that doesn't even have a server component aside from the static web server. And let's go ahead and look at that index file. And in here, we've got a script tag, and we're doing something similar to what we did in our template literal. We are reading from the URL, the user parameter. We're going to insert this hello and the user parameter as the inner HTML of a div and just append that to the body. So let's see what that looks like. We're going to have to log back in. And what we'll see when we log back in is just the username spit out, nice and friendly, hello Twitty. Now, because we are using insertion into the DOM, after the DOM has been parsed and rendered, we know that we can't insert a script tag, but we can, again, use our familiar image and the image on error handler. So let's go ahead and just send that over the wire. And let's see if we can perpetrate this attack. And bam, we spit out our user's cookie out. So obviously not very useful in and of itself, but to prove that we can do this. All right, so now here is a great opportunity for us to use something built in to the DOM itself, the DOM methods. Again, the mantra is never trust your users. If possible, you should just never render HTML out that's untrusted. So what you can use here instead is the text content method, which will instead parse that HTML as a string and spit out the characters onto the screen. So let's go ahead and try and perpetrate that again. If we just refresh the screen, now we just get the HTML spit out. All right, so that is reflected, DOM-based XSS. All right, so let's reset. Our next suspect. Okay, so that brings us to our next suspect in the list. It is cross-site request forgery. Cross-site request forgery is not specifically a JavaScript exploit. It is the harvesting of misconfigured or insecure cookies to forge requests on behalf of a user. However, it's included here because it is very often used in conjunction with cross-site scripting. Cross-site scripting is the most common method for harvesting those cookies or other means, JWTs, etc. It is actually no longer on the OWASP top 10. The most recent top 10 was published in 2017, and the cross-site request forgery fell off the top 10. It also seems to be declining in the common vulnerabilities and exposures database. However, the methodology is in question there in terms of how long it takes to report. So we may just be seeing a trough in this. But nonetheless, this is still a threat. And if exploited, the consequences can be pretty dire. So the mantra here is make sure you know what cookies you're consuming, make sure they're coming from you, make sure they're configured correctly, or eat your own cookies. So let's see what that looks like. All right, so for cross-site request forgery, let's go back to our main application here. And what we're going to do here is we're going to take advantage, again, of the fact that we are using authentication with cookies, and we're going to try to send those cookies off to our evilserver.com. That's sitting over here, proudly serving the evil community and just waiting for some cookies to come to it. And that server has an entry point that looks like this. So over here, we are just sitting there waiting for a post to us, and we're expecting to receive a cookie in the body. And with that cookie, we're going to immediately reflect it back. We're going to go post back to TwitFace and try to make a request on behalf of the logged in user. So let's see what that looks like. Let's go ahead and log in. And we'll log in again as our perpetrator, Evil Weevil. And we are now going to, again, we're going to use our image onload event handler with a smiley face so as not to arise suspicion. And in this case, instead of posting directly back to our same endpoint, our posts endpoint, we're going to post out to evilserver.com. And in our post body, excuse me, we are going to send the cookie of the currently logged in user. So let's go ahead and hit that, and let's look at our network request. And down here, we should see nothing out of the ordinary. But if we log back in as me, we should see one additional post request. And there it is. So this is posting off to evilserver.com. And here we can see that it's sending off our cookie. Let's go ahead and just look at the output of these two servers. You can see here, this is evilserver.com receiving the cookie and making a post and getting an OK response. And then here is our TwitFace server. And you can see it gets a request, a post request to the post endpoint. There's a valid cookie attached to it. It checks to make sure that there's a session attached to that that's still good. There is. And so it goes ahead and makes a post on behalf of me. So now, we don't see it yet, but as soon as we refresh our page, we may see something a little surprising. And indeed, this is really getting bad at this point. So now my boss thinks I'm a Nickelback fan. She's seen me admit in a public forum that I run with scissors, but this one is just crossing the line. She's now seen me post in a public forum, just come out and admit it, that I'm impolite and evil. So I think that this one's going to require a trip to HR. PROCORE is an evil-free company, and I do believe that this violates that policy. So I'm sort of in trouble here at this point. So how do we mitigate against this? The bottom line is, again, only eat your own cookies. So we want to try to make sure that these cookies are secure. If we were posting directly from a client, we could use the same site attribute on a cookie, which basically means only attach the cookie if the request is back to the same site from which the current page is running. But in this case, since we are using a server to make these post requests and are always attaching the cookie, that's not going to work for us. What we can do, however, is we can make that cookie not available to JavaScript such that we can't read it in our cross-site script and try to send it off to the attacking server. So if we look at how we've configured our cookies here, we have set them up to be pretty lax. We have same site set to false, and here, this is the one we're interested in, which is HTTP only. By setting this to true, it means that the cookies are not readable by JavaScript, and which means that when we attempt to read document.cookie, it should be empty. So I have nodemon running. That should have reset the server. Let's log back in as me. We'll still see, we'll see a couple because the last page load will have caused another post request saying that I'm impolite and evil. We should see those two. We should not see any subsequent requests, though, or successful requests back. If we look here at this attempt to harvest our cookie, what we see is that the cookie is empty. And now if we go and see what happened here, we tried to post back, but the cookie was empty. When we did that post request back to TwitFace, we found the endpoint, but as expected, the security middleware redirected us to login. So we've thwarted that attack. All right, so that brings us to our final culprit, which is server-side JavaScript injection. So with the rise of server-side, viable server-side JavaScript programming platforms like Node.js and now Deno, there's a new attack vector that has emerged, which is server-side injection. It's very similar to client-side injection, except it's more dangerous. You don't have a sandbox like you have in the browser that prevents you from accessing operating system resources. The APIs are broadening, but they usually require user input, so you can't just blindly read and write to the file system, whereas on a server, you have access to whatever Node can do or whatever server-side JavaScript runtime can do. You can spawn child processes, you can execute binary files, you can perpetrate a denial of service attack, etc. So it is extremely important to protect the running context of your server-side JavaScript. And just like with client-side XSS, the key here is never trust your users. So you should never accept untrusted user input when you're running server-side JavaScript. Let's see what that looks like. So again, I mentioned that with the client-side XSS, I am primarily concerned with vanilla JavaScript on the client. And so the server has been implemented by a framework, by Node and Express.js. So I've got a contrived example here that is just a simple endpoint running just a simple HTTP server from Node. And it is just accepting posts on behalf of users and then presumably doing something with them, like persisting them to a database. And there's a small amount of code here. It should be easy to spot the error, but if this was nestled in with a bunch of business logic or request logic, it'd be easy to overlook the fact that on line 12 here, we have an eval call. You may have heard that you should never use eval in JavaScript. There are some other languages that support it as well. It allows for dynamic evaluation of code from a string, and it is incredibly dangerous. In general, you should avoid using eval. Even if you think you have a good use case for it, think really hard about it and then don't do it. It's really dangerous. It's fast and easy in this case, and that may be why this person has decided to implement it here. But as we're going to see, it has some pretty dire consequences. So let's go ahead and start that web server up. And we're expecting just to pass it a post. So let's just do an innocuous one. Let's just pass it a regular post. We'll pass it some content. And we'll just pass it a new post. And we've got this running on localhost 8080. And what we should see is just that content logged out here. It's all well and good. So now Evil Weevil comes along and decides to probe. So probing is a technique for trying to find whether or not vulnerabilities exist by doing things that don't require a lot of work but give you back some information. So what if Evil Weevil comes along and decides, instead of sending a post, I'm just going to probe, and I want to find out, A, whether this is a node web server, and B, whether that endpoint is going to let me run code. So instead of sending JSON, I'm just going to send a command here. I'm going to tell it to end the response and send back the word success if that's successful. And indeed, I get back success. You can see in our console log here that content was undefined because there was no JSON to parse. But this tells me a lot. It tells me that this server is running Node, and it also tells me that I can execute code. So now that I know that with minimal effort, now I can do more interesting things like read the file system. So if we go ahead and pass another request here, we can actually read the parent directory and see what's in there. And we get back some interesting things. We can see that we've got a Docker Compose file. We can see some directories, but there's not that much that's all that interesting here, but we could systematically parse through those directories and find other known vulnerabilities. But in addition to being able to read the file system, we can actually write to the file system, which is where it gets fairly interesting. So if instead of reading, we write to the file system, here we're going to require the file system module. We're going to write a file called hack.txt, and we're going to pass it the base64 encoded data to include as the content of that file. And then if we now go back over to our folder structure, what we're going to see here is this hack.txt file that says we've been hacked. So obviously not very malicious in and of itself, but it should be pretty alarming that we can write files. We could write the contents of a binary file and then execute it as a child process and wreak all sorts of havoc on the file system. So how do we mitigate against this? Well, it's pretty easy. Don't use eval, is the nutshell. So what we want to do instead is to use a much friendlier and safer alternative, and that is JSON.parse. So let's do that. So JSON.parse. We've got a catch there because if we send something other than JSON, it will obviously throw an exception. Okay, let's go ahead and restart this server. And now we should just get a console message telling us that our attack was thwarted. Right, so that is server-side JavaScript injection. And that is the last of our exploits. And with the remaining time, I'll open it up for questions. Okay, so we have a question, is this pure JS or also vulnerable in frameworks? That's an excellent question. All of the client-side things that I showed you were vanilla JS. One thing I neglected to show was on the server side, I also have, and I could actually jump back to the code and show that. If we go and look at, if we use the built-in Jade templating language that comes with Express, it builds in XSS protection for you. It sanitizes all user input, but we can opt out of it. So if we go to this guy, let's go ahead and reload. If we attempt to pass that script tag as we did before, and we'll look at the template and see what it looks like. So here, what we see is that by default, it actually sanitizes that script for us, that script tag. If we look at what that looks like, I'm not pretty sure I've got this in the layout Jade. Nope, it's in the index Jade. By default, with this default interpolation syntax, the hash sign, it will sanitize it for you. It does give you an opt-out. And the point being is that quite a few frameworks actually provide an opt-out for users who know what they're doing. If we use the exclamation point here, and we won't need to restart the server because this is just a template. Now, if we reload this, we should in fact be able to render dangerous HTML. So for those who use React, React has a method called dangerously set inner HTML, which is analogous to this. In general, the kind of the point of being really careful with vanilla.js, because as we know, especially since 2015, the capabilities of the language itself have been increasing and negating some of the things we used to rely on libraries and frameworks for. It is possible to build even a fairly non-trivial application with just JavaScript, vanilla JavaScript, using tag template literals as your templating engine, etc. But it is really important to mitigate these types of vulnerabilities. But for the most part, if you're using frameworks like React or Angular or Vue, these things are built in for you. So I'm primarily in the React space these days, and it abstracts the workings of the DOM for you. So React has this component model that's agnostic, and the base component model can be used on top of a web application or a native application. And then it has a library that translates that into a DOM representation called React DOM. And in React DOM is all of this escaping and sanitizing. Another thing that I meant to mention and didn't cover, in general, the point here is to never trust your user input. And further, it's usually a bad idea to ever render HTML provided by the user. But there may be legitimate use cases for that. You may actually have like a blog or something that allows for some limited HTML. And so in those cases, it is incumbent on you to ensure that it's safe HTML. So let's go back to our client-side script real quick. I did forget to do this during the demo, so I really appreciate the question. And let's go ahead and look at what that looks like. So if, for example, we wanted to prevent any kind of HTML from being rendered in these posts, one blunt force approach is we could not use inner HTML and just use text content instead, which we used to mitigate the DOM-based attack. So if we use this, let's go ahead and see what happens now. Maybe this will solve our problem for us. Let's go ahead and log in. And what do we get? Okay, so, well, it solved our problem. We don't see any HTML, but we also don't see the HTML that we're rendering. So clearly this is not going to work, this brute force approach, because we have trusted HTML that we're building. So let's remove that. What we could do instead is target this, right? We saw how we could use, how we could render out these strings. But again, what if we actually wanted HTML here? Well, if we actually want to allow HTML, you have to clean it of malicious tags, malicious event handlers, etc. Now, the right way to do that is whitelisting. If you blacklist disallowed tags and attributes, the permutations there are almost impossible to get right and very dangerous to get wrong. Even whitelisting is arguably a difficult task, and I recommend you don't do it yourself. There is a great third-party library called DOM Purify, which we actually have loaded on the page, and we're going to use for this purpose. And if you do dompurify.sanitize, what this will do is it'll run your string through a set of whitelisted allowed tags and attributes. And then what we'll see if we inspect these elements is that all the event handlers will have been stripped from it. So we log back in, everything's there, but now if we inspect this, what we're going to see is that the event handler is gone. So if you really must render user input, don't sanitize it yourself. Use a library for that. It's really, really important. Any other questions? What modules do you recommend to use when planning an Express API? Helmet, cores, etc. Excellent. So there is middleware. Helmet is an excellent piece of security middleware that does a number of things for you. I do recommend Helmet. Cores, we didn't touch on. Cores is cross-origin resource sharing, and it allows you, so by default, browsers will block AJAX or XHR requests across domains. By default, they're only allowed to run against the same domain that served the current page that's running the JavaScript. But there's a technology called cross-origin resource sharing, which allows you to specify domains from which AJAX requests can be made. There's a cores middleware for Express that's fairly simple to implement. You can do it yourself just by adding a header, allowed origins. And when a request is made, it sends the origin URL along with it. And the server checks if that's in the list of allowed origins, and if it is, it allows the request to proceed. If you are allowing API requests by AJAX, it's critical that you set up cores and restrict it to a set of sites that you trust. You'll also want, common things like a JSON parser for your body, so you can avoid things like we just saw. Bad malformed JSON requests will be returned with an HTTP 400 bad request. The body parser. For authentication, the most popular and widespread set of packages is Passport.js. That's what I'm actually using in the demo here. I'm just using the local authentication strategy, but there's, I think, a couple of hundred different authentication strategies, including for most of the major identity providers like Google and Amazon, et cetera. Any other questions? We have another comment saying another useful module is sanitize HTML. Not familiar with that, but I will check it out. All right, well, I really appreciate everyone showing up for my talk. It's been a pleasure. And if there are no more questions, you are all on break until the panel, which I'll be joining in about 17 minutes. Thanks, everybody. Really appreciate it.